Hi, how's it going, everyone? I'm Kris Nova. We're here to talk about Kubernetes and DevOps and a really exciting talk called You Can't Have a Cluster Bleep Without a Cluster. And the first thing I like to do before I get started is I ask everyone here if you could snap a photo of this. This is a link to my slides, and this is the metrics I'm going to give to my boss at the end of this to justify the trick. Okay, so who here has never struggled with Kubernetes before? Of these people, who here has still ran Kubernetes? Okay, everybody put their hand down. Okay, who here has struggled with Kubernetes? And everybody else just put their hand up. Okay, so why do we do it then? I've been working on Kubernetes for the past 3 years. I'm a maintainer, I'm in a lot of authors' files. I've been involved in the community. What is it that has kept me in here, and what is it that isn't it for me and the other engineers I work with? First off, Kubernetes introduces resilience. This is built into the way that Kubernetes works. There's a database layer that has a primitive called watch that allows you to watch the database for changes. And because of this ability to watch the database for changes, you're able to structure your code in such a way that if something does go in and change, you can be reactive to that. And it's an event-driven or it's a pushed cycle as you're looking at how we manage and mutate things in Kubernetes. And because of this resilience, we're able to build wonderful things that we weren't able to build in the past. It introduces efficiency. Once you get your application up and running in Kubernetes, you can redeploy your application in a matter of seconds. Now, the first time you do this, it might be a little more difficult. It might be a little more worrisome, some of the tooling that you're used to. But the good news is it truly is a technical investment. And once you get your application encapsulated and running in Kubernetes, you're going to be able to replicate that extremely quickly. Kubernetes introduces repeatability. We use the metric system here in Canada, yeah? Yeah, okay, cool. Who here knows where the Fahrenheit system came from? The hottest day of the year, somebody would go out and draw at the top of the thermometer, and the coldest day of the year, somebody would go draw at the bottom. Those became 0 and 100. You'd cut it in half and you get 50. That didn't work for scientists because they were not able to replicate experiments across the globe. So a very, very smart group of scientists got together and said, hey, we know that water boils the same in America that it does in Europe, so let's calibrate a system based on something that we can reproduce on the other side of the world. And that's how the Celsius system came to be. Kubernetes does the same thing. It says, if I can create it on my end, you can create it on your end. When I first started working on Kubernetes, I was working on an engineering team, and one of the working agreements we had was, if you want me to take a look at your application, you have to drop the YAML file into Slack and I'll run it on my cluster. And if it doesn't work for some reason, then it's a sign that something's wrong with your Kubernetes cluster. So repeatability was built into our day-to-day operations. Contrary to all this, Kubernetes introduces complexity. Engineers love complexity. They love introducing complexity. They love talking about when and why it's relevant to introduce complexity. But because of this, we're starting to get a little bit more worried about why we're building out these systems on top of this layer of complexity that we're going to go into pretty deeply in a moment. Because of the complexity, Kubernetes introduces risk. There are more moving parts, there are more things that can go wrong. So why do we do it? What is it about Kubernetes that makes it so powerful? The key takeaway here, and I don't want to go into too much time and just rant about Kubernetes all morning, but the key takeaway here is that the cost of adopting Kubernetes, the flexibility you gain with it, the resilience you gain with it, the efficiency of it, is actually less than the value. In other words, it makes sense. That complexity is worth it because of everything you gain in value out of Kubernetes. All right, let's talk about the cloud. Who here runs something in the cloud? Anything? Okay, who wants to tell me what the cloud is? Someone else's server. Anybody else? Modern cloud computing, and it's reselling electricity at a premium. When I was working at Azure, this is literally what we said. We understood that in a modern data center, if you look at how the data center interfaces with the rest of the grid, electricity comes into your data center, other types of electricity go out of your data center, and your data center makes money. And that's literally the fundamental black box of a data center. And so because of this, we're able to understand that cloud computing is, like you said, somebody else's server, but it's also an ability for us to generate revenue based on software. In other words, the software that's running in the cloud in one of these data centers is what is actually generating revenue for us. So if we look at the modern cloud computing stack in regards to one of these black box data centers, we can break things down into a few different layers. Now this is a Kubernetes stack, and in my mind this is very similar to the traditional OSI reference model. Who here can OSI? Okay, everybody, cool. So we're gonna start at the bottom and we'll work our way up. So at the very bottom, similarly to the physical layer of OSI, we have electricity, which we just got done learning about. On top of that, we have all the machines that we need to keep cool that run hardware, and that's where somebody else's server comes into play. On top of that, we have our first layer of software, and this is where things start to get important. We can either run traditional bare metal or we can run some sort of virtualization. VMware, yay! And on top of that is where we run Kubernetes. And Kubernetes is a fantastic layer of software that doesn't actually require any other containers other than the core components running for you to have a quote-unquote Kubernetes cluster. The reason this is important is because Kubernetes is a layer of software that represents a layer of hardware. In other words, the three main components of Kubernetes are its ability to manage compute, network, and storage. And it does this in a resilient way. In other words, if I was to say Kubernetes, I would like 4 CPUs running in the cloud, and for whatever reason Kubernetes took a look and noticed that there were only 2, Kubernetes would do its best to try to fix that for us. And we get that for both compute, for network, and for storage. On top of Kubernetes, we have tools and add-ons. Who here has ever fought with DNS before? Yay, DNS! That's a really great example of something that would run on top of Kubernetes that you would be quasi-dependent on for your application to run successfully. And last but not least, the oh-so-mighty main function at the top of the stack. The thing that makes your company money, your software. So how does Kubernetes manage all of these different layers? Well, if you look, Kubernetes is at the core, and what you don't see is there's actually an arrow pointing back at itself. But Kubernetes is able to manage the underlying hardware, the underlying electricity, the operating system and virtualization, the containers that make up Kubernetes itself, any tools or add-ons like DNS, as well as your application. What's even more exciting that Kubernetes can do is we can start to look at exciting patterns where we take Kubernetes and we can watch other Kubernetes clusters, or we can have clusters watch the original one itself. So earlier I had mentioned resiliency, and this is a great example of how we can use Kubernetes to not only watch and maintain the stack that we're working on, but also how we can maintain other stacks for us across the cloud, whether that's in our data center or in a public cloud provider somewhere. Okay, so Kubernetes internals. When most folks think about Kubernetes, this is what they think of. A couple of small microservices that when they're all running together, we create this thing that we call a cluster. And all these small microservices are just small executable programs with a single responsibility each. The first one is the API server, which is exactly what you think it is. It just is a REST HTTPS server that takes requests and forwards them on to the underlying database, which is etcd. Ironically, Kubernetes gets a lot of flack for not being able to run stateful applications, but if you look at Kubernetes itself, it's very stateful at the end of the day. The scheduler is responsible for making decisions, and the controller manager is responsible for implementing those decisions. In other words, if I would like to run another instance of my application, the scheduler would tell the controller would then go and start that somewhere. We have these things called nodes. These are where all the work is done in Kubernetes, and these are very simple. On the node, we have its own API server, which means there's a bilateral communication between both the control plane and the Kubernetes node. They talk back and forth. And underneath that, we have the most fundamental piece of Kubernetes with the most adorable name, the kubelet. And the kubelet is responsible for actually starting your application. One of my good friends, Justin, who I also wrote a book with, was able to rewrite the kubelet using less than 100 lines of bash in Docker only. Kubernetes is slightly more complex, and as you start to learn and grow in Kubernetes, this is where that complexity I mentioned earlier comes in. There's things like DNS, or who here has heard of Kubernetes CNI before? 1, 2, 3, 4, 5 hands. Who here knew what that was before something broke? Okay, 1 hand. So yeah, so there are things that make up Kubernetes that are relevant for it to run that you're going to have to concern yourself with. The good news is, though, is that it is a finite set of tools, and it is easy to get started. Okay, so let's look at the big picture. On the left, we have the cloud computing stack we looked at earlier, and on the right, we've expanded our diagram ever so slightly to include the components of Kubernetes. So on the left side, we have the stack. In the middle, we have our main function, which is on top of tools and add-ons in Kubernetes, the operating system and hardware, all the way down to electricity. You can see here that the bottom half of the left side is defined as the cloud itself. And then as we move over to the right, we can see all of the Kubernetes components running on top of the cloud. Also, by the way, containers don't exist. Who here knows what a container is? Okay, somebody shout it out. Namespaces and C groups, that's right. So about 4 years ago, there was a kernel feature called network isolation that inspired the container group, which is sometimes called a C group, that later turned into kernel namespaces. Those were implemented, and whenever we run a process with these really exciting and fancy kernel features, we get to call that a container. But at the end of the day, it's just a regular old process with a PID like everything else running on your computer. The only difference here is we're able to synthesize an underlying computer and storage and network and compute, those same three things we looked at earlier, for the container that's running by itself. So if you aren't sure what containers are, if you're used to using virtual machines, for all intents and purposes, all you have to say to yourself is, yes, it's just a process where we can define how much arbitrary memory, compute, disk, and storage is for our application. Because of the containers, we're able to create these things called container images, which are basically artifacts of how you could restart your application. Underneath that, we have a registry, which is where we would store our images, and we would have some sort of CI/CD system in place to build these for us. If you've worked in a Java engineering environment before, or Python, we're all familiar with the idea of having a build and having some sort of artifact that we go and we run in production later. This paradigm has not shifted at all. All right, the bigger picture. On the left, we have our stack that we looked at earlier. We have cloud, we have a hardware, we have our operating system. We have now replaced at the top middle of the diagram here, fundamentally what breaks down a container, which would be running your main function on top of all of these wonderful bits and pieces over here on the side that we call Kubernetes. Okay, who has questions? No, and the reason I went fast through this is because I wanted to demonstrate that yes, there's a lot going on, and I wanted to give you some reassurance that it's okay, but I also wanted to be realistic about expectations with Kubernetes and what it can do for you. Working on the tool for the past 3 years, I've learned a lot of things the hard way, and if I can boil some of that down in the next about 10 minutes here for you, I think we're all going to walk away feeling a little bit safer and a little bit more educated about what can possibly go wrong with Kubernetes. So let's look at a few of the more famous cluster bleeps that have happened over the past few years. So once upon a time, so this is a really great example. Some friends of mine in Berlin work at a company called Zalando, and this is one of their most famous outages that they've ever had. If you look on the left side, they removed a line that said memory is equal to 50 MI. And on the right, they said, okay, we're going to define a limit higher than that, which is totally reasonable, to 75 MI. They pushed this change, and production was offline in less than 30 seconds. What happened? The PR was merged. A new container was built, meaning that the CI/CD system came in and said, we're going to take this function and we're going to try to redeploy this deployment. It was scheduled to be redeployed, and they had a lot of really fantastic software that was really fast that could go through and accomplish this task for them. So the containers were starting to be brought up in Kubernetes. Remember the kubelet we talked about earlier? It's actually starting these new containers. All of a sudden, they noticed that there was an incompatibility with their traditional software with a new version of the Go programming language they were using. This caused their authentication service to fail because the containers weren't able to start. Because the authentication service was failing, everything that required auth to work started to drop one by one, and the entire system ultimately went offline without any way to authenticate back to itself originally. So what was the solution here? It was a simple solution. It was to harden CI/CD and to implement integration testing. So as they were going through and they said, oh, well, we vendored this new library and this programming language that has never had any backwards compatibility concerns before, we're going to go through and we're going to actually make sure that all of this is going to start and work the way we expect it to before we run this in production. And this is something that they had learned the hard way. Another great example is a time when the Kubernetes layer of software itself came back to hurt itself. Who here is familiar with this CVE? 1, 2, 3, 4, 5. This happened last year around KubeCon. This was one of the most intense CVEs ever released in Cloud Native. This allowed for remote command injection on your kubelet, which we learned earlier is the workhorse of Kubernetes. How did this happen? Very simple. There was a client that would use TLS very securely to talk to the Kubernetes API server. The API server was then able to save those requests in etcd and return TLS encrypted messages back. Now there was a small bug. In the API server, you were able to open up and authenticate one of these requests and leave the TCP socket open. You were then able to escalate through the TCP socket and actually talk to the kubelet directly if you knew how to form a valid kubelet request. The beauty of Kubernetes is we have all of these wonderful libraries in place that make all of this very easy for engineers to do. So once we had a secure connection, anybody could take client Go and go through and actually start interfacing with a random Kubernetes cluster and schedule whatever they wanted to. Furthermore, this was even more malicious because the entire process was untraceable. There wasn't a single log line in the entire system that would detect if this happened. So if and when this happened, we had no way to detect it. So, because of the complexity, we can get ourselves into situations like this. But again, the complexity is worth it. The idea that you're able to build out these systems and you're able to take advantage of these resiliency guarantees based on age-old robotics techniques and algorithms is very handy. So there are many more ways to get into cluster bleeps in Kubernetes. Here are a few. There's a lot that can go wrong, but at the end of the day, the idea that we're all working on this together is what makes Kubernetes so powerful. Imagine working on the world's biggest engineering team with the world's biggest set of regression tests. That's what we have in Kubernetes to this day. So every time one person in Kubernetes learns one of these lessons the hard way, like me, we get to build it in code to prevent it from happening to you ever again. So joining into the Kubernetes community is going to allow you to take advantage of the entire world who's been working in Cloud Native's work into securing and updating your systems. So Kubernetes is complexity that's worth it. But how do you prevent catastrophic problems in this sea of complication? There's ways of mitigating this that we've learned and had to invent, and some of the smartest engineers in the world had to go out of their way to come up with clever solutions to making this happen. Here's what we did. We learned how to mitigate our hazards and observe our systems. In other words, we had to be prepared for chaos, which the definition of chaos says you can't be prepared for it. So how do you get prepared for something that's impossible to prepare for? We learned the power of observability and how that's different than monitoring. Observability says, I want to be able to see what's going on to get clues. We're never going to be able to solve everything if we count just our logs or just our HTTP tracing. But visibility into what's going on and how we can interface with that is going to give us a lot more when it comes time to debugging one of these problems. Furthermore, we learned how to measure our systems. We learned how to say, what is the total output of your system? What is the total complexity of your system? Does it stop at Kubernetes? Does it stop at electricity? Where does your system start and where does it stop? We learned to build out tools to gain confidence. We were no longer building tools to prove and disprove things were wrong like in the days of unit testing. We were building tools that would allow you to walk up to your cluster and feel equipped as an operator, to feel like you knew and were confident in dealing with whatever would come your way, and feeling that you had confidence to manage and maintain these systems. And we did that by learning from our mistakes. So now we have monitoring, conformance, tracing, sanitation, compliance, and observability all working together to give us confidence in running our systems. So it's okay. I know I went fast to get a little lost with Kubernetes. Most people do, but the beauty of it is we're all working together. Kubernetes also brings hope. All of these problems that I just got done explaining to you are now fixed, are now resolved, and you will no longer ever have to deal with them ever again. So Kubernetes is complex. That complexity can be chaotic. Chaos can cause problems, but conquering that chaos is freedom, which is where we are today. Conquering Kubernetes is worth it. Nobody wants another cluster bleep. Thanks. Questions?
Was that the only question?
The question was if I could put my entry link back up, which it's right here. And like Hugh said, I cannot see anything right now. So if somebody raises their hand, you have to jump up and down or something. Rad. All right. Thanks, everyone.